if we break down the deep learning cycle, I think you can divide it into two main pieces. So one is the training phase, in which the model is going through training. Massive amount of data is being iteratively passed through the model, and we have to do these matrix multiplication, matrix manipulations. For that, you'd have to have a very strong compute power. Originally, they started with the graphical processing units. Nowadays, they're actually developing dedicated AI hardware in order to do this in a more efficient way to save some power. So when you're doing the training, because it's a one-time process, you don't really care about the amount of power this training consumes. It is of course important, but not as important as the amount of power being invested in actually serving the application. So when you finish training your application, your AI model, you actually want it to serve. You want it to be within these hundreds of millions of devices. If we're talking about vehicles, then it has to be deployed in many different vehicles. The amount of compute you will have to invest, the amount of data passing through your AI model will be enormous, much more than the amount of data, amount of compute you invested in the training. So we see two trends. One is optimizing dedicated hardware working on data center, which is important in order to serve the training of the neural networks. We see some models in text, in natural language processing. For instance, we see huge models. We talked earlier about GPT-v3. Which is a model with 175 billion parameters. It took more than 1,000 petaflops of compute to train this model, and perhaps the total cost was around $5 million. So this is a huge amount of compute in order to train this. So if we want to get these high accuracy models, we'll need to have this training process perhaps more efficient. What happens when you want to deploy models on the edge? I think the notion, and it's been like that in Brodmann ever since the beginning, that everything is shifting to the edge. So you would like your application to be very close to the sensor, very close to the final customer. We'll start seeing AI everywhere, either in our mobile devices, in our vehicles, in our cameras, everywhere you'll have AI. For that, you'll need to be able to support running AI, deep learning, on edge devices. Of course, edge versus cloud, it's completely different worlds. You have a much smaller compute power on the edge. You are very sensitive to the amount of power your processor actually omits. And of course, you still have to have a good enough accuracy in order to serve the final application. The benefits in running on the edge are enormous. First of all, there are some applications that require running on the edge. You would like to be very close to the sensor. You would like to respond in real time, whether you're doing voice recognition, image recognition, you're inside the vehicle and you want to be able to brake the vehicle. Of course, everything has to be processed locally. Bandwidth, you do not have to transmit your data to the cloud, which is, of course, wasteful. Privacy issues. We have a lot of privacy concerns about this era with many different sensors, all this data being collected. So if you actually allow the processing to be done locally, you mitigate this risk. At Brodmann, ever since the beginning of the company, we wanted to add real value to applications, specifically into automotive. And of course, in order to be able to do that, you have to run on the edge, close to the edge. Because of the difficulties of running on edge devices, we had to go through, let's say, an innovation phase in which we had to reinvent some of the deep learning algorithms, architectures, to develop our own development methodology, which actually is edge-centric. So we're looking at the edge first. Even if we're developing on the cloud, we're looking what is the final outcome, what is the accuracy, what is the power consumption of the solution on the edge, because that's where you need to apply your applications. I think many other companies are seeing that. We see many companies developing specific dedicated AI accelerators specifically for edge devices. Some of these processors are actually sitting very close to the sensor, okay? But we'll still see this dance between the amount of compute that is enabled on the edge and the level of accuracy, the level of requirements, because even as the level of compute will go higher, you'll have more processing capabilities, you will see that the amount of requirements will be even larger. So if you look at an autonomous vehicle, for instance, Waymo, they do not have to process a single camera, they actually have 29 different cameras, and so forth. So we'll see this dance. So the improvements, evolution of AI dedicated chips will have to coexist with the constant improvement in the accuracy and efficiency of the deep learning models and the deep learning solutions evolved.